Okay, like I was saying earlier on, today we are doing what? Projectile motion. What is a projectile? Any object that travels, that a trajectory is the path along which an object travels. If the trajectory of an object is a parabola, if the path along which the object travels is a parabola, this is the shape of the parabola. Do you understand? When we start doing quadratic graphs, right? You see that the quadratic graphs will either be like this, or they'll be what now? Like this. The shape of the quadratic graph is always what now? Parabolic. Do you get what I'm trying to say? So anytime an object travels through a parabolic path, that object is said to be what now? A projectile. Do you understand? If the trajectory of the object is a parabola, what I say trajectory is? The path along which what now? The object travels. Do you understand? If the object is now called what now? The projectile. So a projectile is an object whose trajectory is what now? A parabola. Do you get that? The path along which it travels is a parabola. Can you tell me anything that travels like this? Let me see if you remember. Any object that travels through this kind of path like this.
Rainbow.
The what?
Rainbow.
I'm not serious. Rainbow is rainbow an object. Another that travels through this path. Are you serious? Like
Car.
the what?
Car.
No.
Ferris wheel?
Is that what?
A Ferris
A
wheel.
roller coaster.
Basketball.
Basketball.
What's
So what? My travels what now? In a parabola. Do you
So
understand?
a roller coaster too,
A
yeah.
roller coaster. Okay.
I said
When you play football, you tip the ball, right? It goes what now? In a parabolic path. Are you going to say? Now for every parabola, every projectile, every projectile has two different motions that takes place simultaneously. They happen at the same time. The motion for the projectile, is both horizontal and what? Vertical. It has a vertical part and a what now? Horizontal part. So if, for example, let me say this is a cliff or a high building or a high surface, and I have a ball here, and this is the ground, and I decide to push the ball horizontally. If I hit the ball horizontally, will the ball go horizontally? What will happen? It will go what now? Are you get what I'm trying to say? It will travel in a what? In a parabola. Do you get what I'm trying to say? Now, the force that you gave it is a horizontal push. Can you tell me who brings it down vertically? Who brings it down vertically? Gravity. Gravity what now? Force it downwards. So the parabola is always taking the horizontal what now? Vertical motion at the same time. Now let's remind ourselves some of the things we'll talk about for what now? For motion. Alright? I'll go in with a little bit of but I said that motion is change of position of an object, right? Stop that. Motion is change of position of an object. Then under motion, we have done what? Equations of motion. Let me try and remind you something. When we were defining speed of velocity, the original definition for speed of velocity is what now? Is distance over what? Over time. Speed of velocity is v, right? And then distance or displacement is what? Is s. Are you with me? So speed of velocity v is distance or displacement over time. Remember that what? Speed does not have direction, just magnitude. Velocity is what now? Both direction or what? You understand? Just what we said that what now? Distance is just magnitude. Displacement is what? Magnitude and direction. Are you with me? So, but both of them, when you're talking about magnitude, they are the same. The magnitude for the speed and velocity be what now? The same. Are you with me? It's raining, right? I like rain. Velocity is this. However, we don't use this except for uniform motion. Only for uniform what now? Motion. You can use this one. Are you with me? And we said that apart from uniform motion, we can have, for example, I cannot travel from here all the way to town in a vehicle and maintain the same what? Same speed. Madam, I cannot travel from here to town and maintain the same what now? Same speed. Are you with me?
Yeah.
So that's going to be non-uniform motion, right? For non-uniform motion, usually we say that total distance, hello? Are you paying attention?
Yes, sir.
For non-uniform motion, the speed will now be what? Total distance
Over time taking.
over what now? Over time. And that's not speed, and that's average speed. Right?
Yes.
Average speed is what? Total distance over what now?
Time
taken.
taking.
Or total time. Average speed. And what do we mean by average speed? Average speed is the speed that we expect the object to travel with if the motion was uniform and we cover the same distance for the same what now? The same time. Is that alright?
Yes.
Now that's me just reminding us of things that we already know. Let me try and pull these things together. Then based on all this story, we know how to get the equation of what? Of motion. For equations of motion, the first we talked about was what? Was this guy
S is equal to
u
plus
plus v, right?
Yeah.
We have u plus v over what now? 2
times t.
what? Times t.
Yes.
Right?
Yeah.
Because we have said that what? Average velocity or average speed is equal to what now? Total distance over what? Over time. And what is average velocity? One of the definitions we have for average velocity, we said average velocity is equal to initial velocity plus what?
Plus
Final velocity
velocity.
divided by 2. So if we combine these two together, we'll get this. Now we're having what now? S over t is equal to u plus v over what now? Over 2. If I decide to take t to this side, I will get what now? U plus v over 2 times what now? That's t. Are you with me?
Yes.
So this one is actually from the definition of what? Average what? Velocity. Then we talk about what now?
V.
Acceleration.
No.
What's the definition of acceleration? I said acceleration is equal to what? Change in velocity over what? Over time. Change in velocity over what now? Over time. What is change in velocity? Change in velocity is final velocity minus what?
Yes.
Change in velocity is final velocity minus what? Initial velocity.
Initial velocity.
Final velocity is v, initial velocity is what now? U. So I can rewrite this as what? As v minus u over t. Are you with me? Now if I make v the subject here, what will it become? I will have v is equal to u plus what?
at.
So this second equation and this one they are what now? The same thing. Are you know what I'm saying?
Yeah.
For the second equation we have this. And well, okay, that's fine. Don't worry, I'm sure it's not just calling. What was that?
Razor.
Let me take this that way. So for the third equation, I don't want to waste time.
Yes.
For the third equation, I have that what now? V squared is equal to u squared plus what?
Plus
2as. 2as. So what happens for the third equation? We are eradicating what now? T. Do you understand? We are substituting for t, and then we combine the two, and then we eliminate t, and then we get what? The third equation. For the fourth equation, what are we going to take out? We have s is equal to ut plus what? Half
at
at
square.
Who is not here? Final velocity is not here. If you take away or eliminate the final velocity from the first and second one, you get what now? The fourth. So in the first one, what is missing? A is missing, acceleration. Second one is missing distance. That's s, right? And then the third one was missing time. And for the last one was missing final velocity is missing. So I told you if you want to remember what now? ASTV, like you have DSTV, right?
Yeah.
So this one is going to be Aliyah State Television, right? Right? So like you have DSTV, you have what now? AS what now? TV. The first doesn't have A, the next doesn't have what now? S, the next doesn't have what? C, and the next doesn't have what now? V. So if you're going to do any calculation that does not have a use for what now? For acceleration, you're using the what? The first. If you don't have